So this is the, good morning everybody, I'm John, the first one on this list here. This is the software management course that we organized really because here at CSCS we tend to work with a lot of people who have either just graduated, that kind of thing, started working on a project with us. They sometimes don't know some of the tools that we use all the time, like Git and CMake. CMake is the big one, really, because it really determines how your project gets sort of used by people outside. And it's very annoying when you make changes in your Git repository and then somebody overwrites them with rubbish and deletes them, and you think, God, don't these people have any training or whatever? And I've been using Git and CMake for years and years and years, but I've always let things like Jenkins, somebody else has already done, always sorted that out, and I know nothing about that. And so it's nice to have somebody tell us how to use Jenkins, how to use things like EasyBuild and Spack for deploying your projects on other machines. We have the big machine here, Daint. We have several other machines, but then we often have collaborators who say, oh, could you set it up on my machine? So you end up SSHing in, and then you copy the scripts that you set up on one machine that you put onto another machine, and then it turns out they don't quite work. And I'm told that EasyBuild and Spack make that easy for us, so hopefully we're going to find out. So I'm hoping to learn quite a bit about those last three. The reason I'm teaching you guys Git is because for some years now here at CSCS, whenever anybody accidentally wipes everything and says, oh no, I've deleted everything in my Git repository, how do I get it back? They used to always come and ask me how to do it. And CMake I've been using for years, but one of those things is when you're using something for years, you tend to get into bad habits, and CMake has been evolving. And so what's this course for? The course is for people who haven't worked on big teams before, collaborating and sharing code, and to learn about these tools that I've just mentioned. There's a kind of life cycle in terms of how code goes from being something which sits on your disk that you're playing with, something which is actually a product which is out there that people are using. And it kind of, Git is your daily routine for committing changes, making stuff. CMake is building it, running it, testing it. Jenkins, integrated testing, and then EasyBuild and Spack deploying it. And these make up a kind of life cycle. And there's more tools which, as we're putting this course together, I think, hey, we should have included a bit about this, and we should include about this. And this is the first time we've done this course. So it's kind of experimental. And for example, my Git slides, I started putting together material, and then I thought, oh, I need to mention this, I need to mention that, and it's a total mess. So it's mostly going to be just the command prompt terminal kind of thing, and showing you how I would fix things if I were doing it, and not so much of a lecture, more as a kind of random series of examples. Hopefully the CMake stuff is a bit more well thought out. We'll see as we come to that. Jenkins and Spack, I leave it to the other guys. In fact, we've got one chap from, I think the EasyBuild guy is going to be doing his presentation tomorrow remotely. And then remind me, this morning we're doing Git, then we're doing CMake for 2 sessions, one before lunch and one after. And then this afternoon we're doing Spack. Yes? EasyBuild, sorry. Then this afternoon we're doing EasyBuild. Then tomorrow we start with a couple more CMake sessions, and then Jenkins and the other one that I said, which I've muddled up, what the other one of them. And the reason we broke the CMake up is because if you had to sit for a whole day and just do CMake, you would go mad. It's just too annoying and too much pain. So having a bit of it on day 1 and a bit of it on day 2 and interspersing it breaks it up for you. And this is the summary of what I've just been saying. At some point, you graduate from being just a guy hacking away on your machine to actually working in a team. Usually when you graduate from your course and you actually get a job or you become a postdoc or something of that kind, and you're working on a common code base with people like me, people like you. We're all part of, I presume we're all part of teams. Is anybody not working on a team at all of code? I mean, everybody. Excuse me, everybody's working with a team of some kind. So you have coding standards, you have testing, you have customers or users, which these are the worst. Users are the worst because this is what makes the difference between when you're just knocking out your own code and when you're providing code that other people are using. This is where things really change. As long as you're working on your own code, you can do basically what you like. Once you start giving code to other people and sharing it, that's when everything changes. And you have to start thinking about long-term maintenance. You release a version this year, and some people are still going to be using that version in 2 years' time, even though you've moved on and you're working on you have to think about these kind of things. So these tools are the kind of things you're going to need to learn about at some point, and it might as well be now. And so, as I said, it's the first time we've given this course. Please ask lots of questions. As I said, in particular, the Git stuff, it's completely random. It's just like, oh, I've got a thought, they need to know about this. Oh, there's another thought, they need to know about that. If you ask lots of questions, and that's one reason why we sent out the little questionnaire, is to find out what you guys know and what you don't know. And so ask lots of questions, interrupt constantly, say, oh yeah, but if I accidentally did this, then how would I fix it and do that? And then we can show you, because it's really the best way to learn is by messing things up. And so if you've got a repo, for example, and you want to know how to do something, then just ask and we'll try and accommodate it. And the sessions, we can make them flexible. If you want extra 5 minutes on Git or you think it's enough, please stop. We can start the CMake one early. I presume Hannes is ready to take over at any point. So we'll get going. We'll see how it goes. And hopefully everything will go according to plan. So this one here, I think I'll just keep the slides. Well, I'll put them in presentation mode, but my plan is to switch between. Actually, there's a question for you. You see, I didn't even finish the title. That's how bad it is. I was thinking, what do I want to call it? It's how-tos and everything else. And actually, I didn't put very much stuff about workflows in it. So I should really edit that. The first question is, does everybody have access to a bash terminal? Yeah, I mean, there's nobody who's on like a Windows machine and doesn't use any kind of putty or any kind of bash or anything like that, because I'm assuming, okay. And incidentally, I think most people know quite a lot about Git already. So if you want to just check your emails and don't pay attention for this part and you're here for the CMake, that's not a problem, carry on. So where did Git come from? If you're a little bit old like me and you grew up programming in the 80s and 90s, then you used things like CVS. And I mean, CVS was amazing because you could develop code and you could make changes to it and you could do diffs between one piece of code and the next, and you could see the changes and you could give them to other people and they could work on it. And you said to yourself, how on earth did we cope before CVS? And then SVN, Subversion, came along, and it made things like branches a bit more easy to handle, and it was a much nicer workflow, and you thought, goodness, how did we cope with CVS? CVS was so terrible. And then Git came along, and that kind of, for me, has blown away everything, because Git does everything. And I was thinking to myself, if something comes along to replace Git, what will it do that Git doesn't do? And I can't really think of very much that's missing. So Git, for me, is like a state-of-the-art. It's really a fantastic tool. And it's all about version control. And I'm sure you guys know all this, so I'll go over the intro. And as I say, if you want to just check your emails, carry on. But your code consists of a sequential series of changes which constitute diffs from one point to another. And the way CVS used to store things is actually storing physical diffs, so that you had the file, and then you had a diff, and you had another diff, and they made a string of diffs. And you could actually go back in the history and change the diffs manually, and then the whole repository would change. And you had to be very, very careful, because it didn't have any kind of rigorous maintenance of how these objects in this tree of changes were kind of connected. And with Git, each commit represents a new state of the whole repository at some point in time. And this is something which is quite different from previous tools. And of course, there's tons of other ones out there, like Mercurial and Bazaar and all these other. I don't know anything very much about those, so I won't try and go into them. One of the questions that we had, one of the questionnaires, somebody asked about maintaining, like if you've got code in one tree and one code in another. So ask about that when the time comes. And so diffs is the basic sequence of steps that go from one to the next. And of course, when two developers or one developer working on two different things start to diverge, this is when you get branches forming. And commits tend to have parents, and branches have more than one parent, and you get these kind of trees forming. Now, when I do when I do any terminal, I meant to print this out, but unfortunately the printer upstairs wasn't working this morning, so it didn't come out. But I use a lot of aliases, so shortcuts. Now, if you've used Git much, you probably have a lot of shortcuts set up. But when I'm typing on the screen, if I do some little examples, I'll probably type in shortcuts. And I've actually checked them in to the CMake repo, so you can look at them. But when we come to them, if you don't know what I'm typing, just butt in and ask. So the questionnaire we sent out. So most of you said that you were quite familiar with Git and you know how to use it and basic command line stuff. There's only one person said that they're a bit rusty on the actual command line things. Everybody wants to know about the best practices. So the best way to organize branches, the best way to organize merges, the best way to set up a repo where you're collaborating effectively and how to maintain and manage it. And I like that. Avoiding chaotic code developments, because that's kind of how we tend to work, and forcing some rigor into it is the trick. And merging. There's different ways of merging whether you squash, whether you rebase, that kind of thing. And then obviously managing conflicts, when to rebase, when not to rebase. And hooks and submodules. Somebody asked about hooks, and so I thought, I never use hooks. I mean, I know how they work and everything, but I never actually use them. So I experimented last night creating a hook, and I thought, okay, that works, it's fine. So I've got one of those checked in, but I'm not really an expert on that. And likewise, submodules. I use submodules, but I would never force someone else to use them because they work, but they're just annoying. But I'll show you some of the problems I've had with submodules in the past. And then integration with Jenkins. I'm hoping that when Theo talks about Jenkins, he's going to mention how you integrate with GitHub, because I didn't actually cover that. So obviously you know how to create I presume everybody knows how to create a repo. One of the great things about Git is you can just say git init dot and create a repo right here, even in an existing source tree. If you've got some code that wasn't being maintained by Git, you can just say create a tree, git init, and there's two kinds of tree usually, not usually, there's two kinds of tree, and usually you'll have what you would call a working copy of the tree. But when you're creating a copy on a server somewhere that you're just going to push to, that other people are going to push and pull from, then you tend to use the git init -- bare. And you can let Git do the work for you. Now that init bare, I actually use that, like for example, on Ella, which is the front end to our systems. So before GitHub existed, before we had all these free repos on the web, what I used to do is I used to SSH into Ella, and git init bare, a repo there, and then from home, from the office, from working remotely, I could always access Ella, and I would have my repos backed up. And effectively, you can set up yourself a free backup service by creating an empty repo and then pushing to that somewhere. And using a machine like Ella, which is open to the public, but it's also password protected, it's a very nice way. So the bare is the only time I've ever needed to use the git init -- bare is when I've been setting up my own little backup repos, effectively. So bare repositories, as I just said, they're used as a hub where lots of users can push and pull from. And I mentioned that just there. The only real difference between a bare repo and a normal repo is that in a bare repo, the .git folder is the root. And you see all the internals of Git. Whereas when you have a normal repo, when you just init, that .git folder is in a subdirectory and you don't tend to see it. But that's really the only difference. So what makes Git really kind of awesome is this fact that it's distributed. CVS and SVN, you had to manually copy the tree from one machine to another. And then if you made changes in one tree and changes in the other tree, there really wasn't any way of ever synchronizing them back again without manually going through these diff file type things. The SVN subversion might have had some ability to resolve those, but it really wasn't designed to be a shared set of repositories. What Git does that's so amazing is this ability for everybody to have a copy of the repository. Everybody in the room can clone one repository. Everybody in the room can make changes to that one repository that they think is their master copy. But those are all referencing another master copy somewhere else, and everybody can then synchronize on that And this is what makes collaborative work so much easier with Git than with previous tools. Every copy or every clone of the repository is in some sense complete. I can create a repository and I'm going to put all my work there, and I've spent years on it, and it's got tons and tons of code in it, and then you guys clone it, and now you can make branches, you can commit things to it, and your copy is just as complete as mine. And then at some point we can synchronize those, and I can say, oh, you've done some amazing stuff here, let's have that, and other people can add, and you can just keep adding like these little hubs, and it just gets more and more interconnected. Everybody can work on their branches, and pushing and pulling is the basic mechanism for basically pulling work from somewhere else or pushing your work to somewhere else, and we'll just briefly talk about that. And don't be fooled into thinking that cloning lots of remotes is really expensive, because it's not. And we'll talk a little bit. I'm not a huge expert on how Git actually works internally, but I've got a nice little demo, which I think you'll like, that shows you how it does stuff internally a little bit. So when you clone, you're effectively making a copy of someone else's repository, and by default you get all their branches, all of the stuff that's in there. And in general, you clone someone, and whoever you clone from is the origin, and by default you get the master branch, which is the way most people work. It's easy to forget that as soon as you've cloned someone's repository, you're effectively buying into 3 copies of everything. And the question is, why 3? Because you have a repository, and it has a master branch, and I clone it. And now I have a copy of your repository, and I have my master branch. So I've got my copy of master and your copy of master. And you're now going to work on your master, and yours changes, and I'm going to work on mine, and mine changes. But there's still a 3rd copy, which is when I originally cloned you, I get in my Git folder effectively a pointer which says when I cloned you, where your master branch was. So when you clone a branch, in your I've forgotten what I was going to do now. Let me pop into a different repository. So I'll make the font slightly bigger. Can everybody read that? My eyesight's not as good as yours. So when I cloned the HPX repository, the master branch is effectively put into a reference. So the head of master branch is my point at where my master branch is. And I have a copy of where the master branch of the remote repository that I pulled is. And that's effectively, the reason why you have these 3 copies is that there's the original, there's your copy of the original, and then there's your actual working copy that you're developing on. And this one might change, and that one might change, but this one in the middle, this copy when you first cloned it, that one is always there. And it's only when you push and pull and you do fetches that that one gets updated with the remote one. And it's sometimes easy to forget that you've got this 3rd version, or at least when you're new to Git, that there's a 3rd version of the repository. So when you add a file, it tells Git that you want to contribute some material into the repository, and it puts it into a staging area. And it's confusing because some people call it the cache, some people call it the staging area or the staged, and some people call it the index. And in the docs, in the man pages, it's usually referred to as the index, but I was always brought up calling it the staging area. So there's a bit of confusion. But basically, Git is internally maintaining a database, and I'll come to that in a second. And what you're doing is you're saying, I want to put this stuff into the repository, and it goes into this staging or indexing area before it actually is committed and becomes part of the tree. And the question, why do we need the staging part? Why don't we just commit things to the tree? Well, if you have to time travel back to 1990s and use CVS and SVN, and then you'll understand, because in those versioning systems, when you did an add, basically everything in your source tree got added, and that was it. You couldn't add bits of it. You couldn't say I'll add a bit and then I'll add a bit more. You couldn't mix and match these things. There was a single command which said, here's my copy, and now that's the new version. Git allows you to say, add one file. Oh, no, actually, I changed my mind. I won't add that file. I'll add half of that file, and I'll add a bit of this file and a bit of that file. And you may be working on something, and you actually fix two things. You fix a bug, but you realize the reason why that bug existed is because someone did something wrong over here, and so you fix that as well. But really, you think that fix isn't, that's a different fix. And so you really want that to be two commits so that people know. And this is something you can do with Git that you couldn't really do very easily with CVS. And that's why there's this staging area. It allows you to incrementally add stuff and do things a bit differently. When you make the commit, then effectively the stuff that you've got staged becomes part of the next point in the branch. And it's very important to note that all commits are in a sense equal. And there's no real difference between a branch and just any other commit in the repository. They're all exactly the same. And people frequently don't quite realize that if you're on a branch, and I'm on the head master branch of Stella, and these are the commits that I'm looking at going back in time, and if I think, well, I don't actually want to be on the head, I want to be, CO is a shortcut for checkout. If I want to be on that commit, I can check out the tree at some random point. You don't have to be on a branch, and you don't have to be on a tag. You can just check out any piece of code you want at any point in the tree. And this is really something where Git differs from some of the other tools we've used in the past. And a branch is just any commit in the tree with a special name. And when you commit to that branch, it gets updated and it moves. It moves up. And a tag is one where you can effectively say, that was the release, tag it. If you ever change anything in that release, like you update it with a patch, you'd have to manually move the tag. So any commit can become a branch at any point by simply creating a branch at that point. And you can just type git branch, blah, 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 and put the tag for that, the SHA for that point in. When you start checking out points in the tree which aren't points of branches, you can get yourself into what's known as a detached head. You'll see this message sometimes when you try and pull from somewhere or push to somewhere, and it says you're in a detached head. It just means there's this tree of commits, and you've managed to get yourself onto a point which doesn't have a name anywhere. So Git can't really help you track it. But you can just create a branch at that point. This is the point where if you say, I'm confused, you stick up your hand and you say, show me what you mean and everything. So when you clone a repository, you get the origin. But you can add as many remote clones as you want. By way of example, the first thing I do most mornings is I do a git. I use an FA, which is a fetch all, and it's actually fetch -- or, I think is the correct. I never actually type any commands. I've forgotten how to type most of the commands. And you can see origin, that's the main HPX repository at Stella. I've got my own clone of it, which is the GitHub one. I've actually got an alias set up, which is the same repository as origin. It's just called Stella because I sometimes can't remember which one. Well, I can, but I've got two copies of it, effectively. Then I've got Hartmut's branch, which is on GitHub. I've got Thomas's branch, which is Hella. I've got one local tree, which is just in a different subdirectory. I've got another local one, which I call local Numa, because I'm working on a branch there, which is quite a long one, and so I keep it there. I've got Augustine's, I've got Mikhail's, and And I've got another local one here. So I think I've got, I don't know, 8 or 9 different copies of the HPX repository. And each one of those effectively has the same tree of commits, but everybody's got something a little bit different. And if you were to use some tool like, yeah, you can't see very much. I don't know if everybody knows it, but when you install Git, you nearly always get Git K as well, which is quite a useful little tree browser. And if you do --all, it basically shows you all branches. If you just type git k with no parameters, what it will do is it will show you the branch you're on as the main focal point, and then it goes back in the history, and then any branches which happen to kind of come into there, it shows them, but it doesn't show other stuff unless you specifically ask for it. And if you specifically say, I want to see master and let's say Stellar master, then it should be able to say, well, look, my master is, my master's here, but the other one has been updated with a few that you can see where the merges are coming in. I don't think I can make the font, but you can see my master is down here. Meanwhile, development has moved on, and there's been a few merges of branches coming in, and the new master is up there. And so this fetching, so when you fetch this FA, fetch all, I'm fetching from all the repositories that I'm working with. When you fetch, your local copies, not your working copies, but your just local references of all those other people's branches are updated. So that third copy, you're working on this, they're working on that. When they push to their repository and you do a fetch, effectively your third reference is updated to point to whatever the branches are on those. Now it says everything's up to date. I'm fine, I'm happy, no problem. So when you fetch, you effectively get all the updated branches that everybody's working on, and nothing changes remote on on remotes that you're working with unless you push to them. And what's the difference between a local branch and a copy of between a local branch and a copy of the remote branch? And it's really this business of having the ref in that Git repository, in the Git subdirect. Forget this. I was going to do a quick example here. I was working on the. So for this course, Hannes created a CMake repository with material in, and I cloned it from CMake training, whatever that is, and you can see. No, that's the wrong one. That's the wrong one. Okay, so I'm hoping that's... So Hannes created this repository here, which is in his own personal, and I cloned it. And then on Friday, we decided it would be better to put it into ETH. So on my local disk, if I say RS is short for remote show in my aliases, then my origin is pointing to Hannes's copy of the repository. So I will only get anything which is in Hannes's local copy, or his GitHub clone of it. Now, if I want to pick up the latest stuff he's got, I need to add another remote. Now, fortunately, we can just do that by going to here, copying this bit here. And I can say git remote add, and I'll call it ethz, and put that in. And then do git fetch from all of the different versions of the repository. Now the origin one, which is Hannes's one, it should be up to date. And then the ETH one, I'm hoping over the weekend he committed some stuff. And hey presto, now I've got some new branches which he's put in during the weekend. Now I have 2 copies of the same repository. And you might think, okay, now I'm using twice as much disk space, and it's just pointless because why do I need 2 copies of the remote? Well, it just doesn't quite work that way. And what I would like to hopefully show next, and I don't know if I put the slides in the right order. Whoops, that's the wrong one. Oh, I lose my point in the... That's... So well, there's an interesting thing there. So sometimes you'll find a case where you're working on a repository, and then the developers move it somewhere. Well, in this case, it's fine. What I can do is I can go git remote and what I want to do is set the URL. And in fact, I don't actually, what I'll do is I'll do it a different way. That was the slide I forgot to do at the very beginning of this, is that there's no right and wrong way of doing things in Git most of the time. There's usually loads of ways of doing the same kind of thing. So now I've got, yeah, question?
Just tangential is when you had very many people had their own version.
Oh, does this one work? Because we're recording the, I don't think anybody's ever going to watch this, by the way. But since you're asking a question, you might also use it.
Hello. Yeah. So you just show how you fetched a bunch of different people's version of the same master there. So what's the reason for doing like that instead of everyone pushing to the same, let's say, under the Eto Jose repo and you pulling from there? That you want to have that many, they all have a, let's say, repo somewhere in the GitHub?
Several reasons might happen, which are, firstly, it's convenient for you to have your own copy of the repository. And so for example, I have my own clone of HPX on GitHub, and I push branches there when I'm working on them, but I don't think they're ready really to be merged into the main. Now, so there's the official repo that the public sees for HPX, for example. I work on HPX, I didn't mention that, but it's a big project. I'll show some stuff. Now, the public repo is the public, everybody who Googles HPX gets pointed to that repo, and they clone it, and then they start building it, and they play with it. Now, they don't want to see all of my half-finished work, and my stuff that maybe doesn't build properly, and my interactions with some of the other developers. So I have my own private copy on the laptop, and then I push stuff when I want to back it up effectively to my clone on GitHub. Those branches go there, they can sit there. If my laptop gets stolen or burnt or something, I've still got everything backed up on my repo. And at some point, I can then do a pull request into the main repo. Now, what I normally do is I would push things to my GitHub clone of HPX, and when I think a branch is basically finished, rather than doing a pull request from one repo to the other, I usually push my branch to the main HPX repo. But we've actually set the main HPX repo up so that it has permissions so that only limited people can actually push to it. So there's a second question there, is also security. So a nice thing is I can clone HPX on a machine like Ella, which is behind a password-protected SSH. And now, let's supposing I was working on a project where I had some confidential code. I was working with a third party, it was under NDA or something. I can push branches to my repo, which is on the machine, which is behind the password. And it's still synchronized. I can still manually synchronize those branches. I can pull from master in the public, update, do merges, that kind of thing on my private copy behind the firewall. And somebody else who's working with me presumably also has access to that machine. They can SSH in, they can get my branches, they can pull and push to that as well. And so this is one of the things that makes this whole distributed nature really rather clever, because you can share with anybody and you can share with everybody, but you can also keep stuff just for yourself and only make it visible when it's really necessary. I forgot now what I was about to do. Oh well, I lost my point in the slides. Oh yes, because, so there's two ways I could do. So at the moment, my origin repository, I'm going to sit for this and do that. My origin repository points to Hannes's copy. So if I say remote show origin, it points to Hannes. But really, I want the origin now to point to the ETH one, because that's going to be the official one which we're going to maintain after this course finishes. So two ways I could do it. I could either rename the origin one to the ETH one and vice versa, or I could manually set the URL from one repository inside your... Oh, I'm in the subdirectory already. Inside every Git repository, there's a whole bunch of inside each repository, there's a little text file, which is the config, which shows you where things are. And you can see that the remote origin points to Hannes, and the ETH one points to the ETH one. And really what I'd like to do is change these so that this one is the origin and this one is Hannes. And then everything's fine. Now, you can manually just edit the config files and do that, but that's usually not a great idea because, for example, what you find is that this branch master, it says the master branch, I took it originally from origin, and the ref to head master is pointing to the origin. Now, if I change the repository which origin points to, then that sort of link to what the master branch was on Hannes's repo is now pointing to the master branch on the other one. Now, it actually doesn't really matter most of the time, things like that. But instead of saving that, you can say, for example, remote. Now, I forget the syntax, but I think you can say rename origin to temp. And then you can say rename, did I call it ETHZ, to origin. And then rename temp to Hannes. Oh, I've spelled it wrong, sorry. And then if I go back to that git config file, it actually noted, it made a point of saying, that remote that was origin, where that branch was pointing to, refs headmaster, isn't pointing to origin, that's pointed to Hannes. So it did some of that little bookkeeping for me. So it's safer to use some of those built-in commands. But this happens actually surprisingly frequently. You're working on a project, and then the developers say, oh, we're going to move from GitLab to GitHub, and we're going to move from GitHub to a private thingy, and the URLs kind of change, and you don't want to get yourself into a point where this recently happened as well on a project I was working on where everything just completely went away. And it's important to note that you don't lose, I mean, this isn't a big deal. So this is where I wanted to actually show something reasonably interesting. So a comment about blobs. So Git doesn't store your files. So when you say hello world.txt and you create a text file and you go git add hello world, git commit, nice new file, it doesn't store your file as such. What it does is it breaks your files into chunks, which we refer to as, well, I'm going to just call them a chunk. I don't know what everybody else calls them. And each of those chunks then gets compressed and stored as a blob. So your file is just a list of blobs, which are then decompressed. And a branch is a list of pointers to a state, where a state represents a whole bunch of blobs. Now, the whole repository is basically a database. And each commit represents, if you like, one possible configuration of the data in that database. And when you do git checkout and you check out somebody's branch, Git isn't just going into it and saying, oh, let's find that branch, which is what SVN and CVS used to do. They used to store the branch as a physical copy of the branch, so that each branch was another copy of the whole kind of tree. What it does is it goes to the database and it says, right, at the point in time represented by this commit, and the point in, I won't call it space, but it's not always time because people can be working on different branches at the same time. So it's not a point in time, but it's at the point in the tree of the commits. Then give me all the files that represent that point, and it pulls them out of the database. And there's a nice little demo you can do, which if you were to now clone For the course, we would like you to clone the updated version of this onto your local disk, because for the CMake part of the course, Hannes is going to want to give you some examples. So if you can do that now, assuming if anybody needs help cloning this, then just ask. I'm assuming you'll know how to do that. And I highly recommend using the SSH form. I didn't actually explain the SSH and the HTTPS, but I've got a slide somewhere later on in the deck which refers to that, if anybody isn't familiar with. Has anybody not done any of these basics before? I mean, everybody knows about cloning and that kind of stuff, yeah? But if you clone this course, now what I haven't done, which I'll do in the background, you'll lose this text, so if you need me to put it back up in a second, I will do. I haven't pushed all of my branches to the ETHZ. It's now the origin, isn't it? Oh, I spelled origin wrong, because I'm an idiot. O-R-I-N-G, O-R-I-G-N. Now, I've got 2 or 3 branches that I was working on in preparation for this, which I'm now going to say push all. Now, I highly recommend that this minus minus all you don't use very often at all, because it's very rare that you want to push all of the branches you've been working on to somebody else's repository, because especially if you put minus minus force on it as well. I will just, it says that it can't, okay, so you've all had this error message before, I take it. The one where it says you can't push because your tip is behind its remote. Has anybody never seen that before and not know what to do? Everybody knows what to do, yeah? I'm trying to push my copy of master branch to Hannes's, but Hannes has moved his, and I'm not allowed to do that. I'm going to just show the branches that are on origin, and okay, well, my branches have been pushed, the ones that I care about, so that's fine. Okay, so now everything's up to date. Now, I did a little rebase there, which I'll come to as well. Rebasing is a source of great confusion for lots of people. Now, what I wanted to, did everybody succeed in cloning that repo? If you do clone that repo, check out the branch called, let me just have a look. Oh, I've just done it there, it's there. Check out the one called git files, that branch there. And in your repository, there should be a little git. There's a CMake subdirectory, which is Hannes's stuff, and there's a git subdirectory, which is mine. And in that git subdirectory, there's a file called test_1.sh. And this is the wrong version of it, but it doesn't matter. So I'm going to make this. Can we dim the lights at this end? Because the screen's a bit washed out. Do we know how to do it? Okay, that's better. So in that file, there's a single one-line piece of text there. Now, what I'm going to do is I'm going to make a temporary directory somewhere else in the file system. And I'm going to say git init git test. So I'm going to create a new Git repository called git test. And I'll make my font a bit bigger on this window as well. So you can see I've just created, and I'm going to cd into that git test. And if you look at it, it's completely empty. And if I do a git log, it says there are no commits in here at all. Completely empty, brand new Git repository. Now I'm going to paste in this one line of text, which says 8,000 times, which is 2 to the power 13, 128 x's, which is 2 to the 7, which gives me 2 to the power 20 x's, and I'm going to do that. And 2 to the power 20 is 1 megabyte. So I've just created a text file called x, which if I were to do cat x, it's basically a million x's. And I'm going to say, great, that's fantastic. I'm going to add x to my repository and say git commit. And by all means, try this, because it's kind of awesome. So I've now committed lots of x's. And if I do an ls-al and I ask for the size in a readable form, it says that my x.text is 1.1 megabytes. And you know that it's there, and it's wonderful. And if you delete that file, it says the git is short for git status in my aliases. It says, oh, you've deleted x.text, and I can get that file back by saying, I'll just say checkout, co, the roots where I am. And now I've got the x file. So there's 1 megabyte worth of x's stored in my Git repository. And yet, how is it that I've got 1 megabyte in my current folder, but the .git folder where everything is stored is only 168 kilobytes? Somehow it took my file, which is 1.2 megabytes, and it stored it in a tree with only a couple of hundred K. And it gets worse, because if I say, well, okay, I'm going to take one of these x's and I'm going to change it to a y, and now I'm going to say, okay, I'm going to add my x file, and I'm going to say, and you can see that I've got the original x's, and I've now got some y's, and if I do a cat, or if I do a head of x.text, you can see the y's are in there on the left-hand side, and now I can look at my Git repository, and now I've got 2 files in my Git repository. Both of them are a megabyte, and it still only takes 196K for the whole repo. So how is it doing that? And the way it's doing that is it's because it breaks my file up into pieces. Each of those pieces becomes effectively a chunk, which it then passes through effectively a Z compression filter, you know, like a tar gzip thing. It then stores each of those blocks of file and puts it into this database and gives it a commit. And the commit says, this file is represented by these blobs. Now, the X file and the X file version with the Y in, most of the blobs for that are absolutely identical, so it doesn't need to copy them, and they're compressed. And most of your code is written in text, and it gets compressed. So when you now, if you were to clone my repo and copy it onto your disk, and then everybody in the room were to make a clone of it, and they all had a copy of this tree, and then everybody were to start adding each other as remotes, you could have 20 people all with copies of this tree, but there's only one set of blobs. So when somebody commits some file to your repository and creates some new stuff, and then you add a new repository, you clone it, and you get their branches, you're not really getting copies. You're just getting these extra blobs that are different from your copy of the repository and their copy of the repository. It's usually just a few blobs that are different, and you don't get this massive. So me having 9 copies of the HPX, now the HPX repository, just out of curiosity, if you look at it, this is 20,000 commits, 98 contributors, and it's almost 11 years of development. It's massive. And having 9 copies of the repository basically costs the same as having 1 copy. So I can add tons of these remotes, and it's not a big deal. So you mustn't be worried about having too many remotes and ballooning your repo. So Git tracks the content, not the files. So this is how it does its other things. So if I, for example, do this, if I say vix.text, and I'm going to put another y in here, let's go overboard and put some z's in as well. And I'm going to move the file x to xz. And then I'm going to add xz. And I'm going to say, oh, it did it for me in this case. It says I've renamed x to xz. Now, normally, let's just, I didn't want it to do that. That was too clever of it. It says I've deleted the file x because I've actually changed it to xz. But if I say git add x, I beg your pardon, it says I've typed something wrong. Oh, I've added xz. Let me do it again. You get the idea anyway.
No, but this is correct now.
No, but I didn't actually want to do that. What I wanted to do was say, look, I've deleted x, but I haven't added xz yet. So let's add x, the deleted file. So you can actually add a file that's been deleted. What I'm doing is I'm saying the fact that I've deleted x from the sort of index, if it's from the repository, I now want to add the fact that I've deleted x into my history. And so if I do this, it says, oh, you've deleted x, but there is a new file in your directory which I'm not tracking under Git. And so I'm now going to add xz. And then it says, well, I've renamed x to xz. Now, how did it know that I renamed x to xz? Because it broke x into all those blobs, of which there were, I don't know how many. And then it broke xz into all those blobs, and it said, well, actually, there's 1,000 blobs in this one and 1,000 blobs in this one, and there's only one blob different in this one and this one. They look like the same file. The fact that you've deleted one file and you've added a file, you've probably renamed it. This is kind of your proof that what's going on inside Git is that it's actually tracking the content of your files, not the names of the files or the relationships. It's really tracking what's in them. So that's the end of this little example. I find that really rather shocking, the way it actually handles this internally, how it manages it's a database. It's a file system in its own capacity, a database file system inside your file system. And so the Git folder tends to be much smaller than the working tree when you're working with So now when you think about commits and branches and tags, you think about all I'm doing is I'm looking at combinations of these blobs and how they piece together. And so when you build up your tree, you can effectively be saying, this branch is exactly the same as that branch, except it's got a few blobs here, which are represented by these file names and whatnot. And each commit is effectively a snapshot because it's a database. It's not just a copy of your files. So, of course, the thing that happens when you commit things is you get diffs. Diffs are your main kind of tool when you're working with merging things and whatnot. Now, a few people said handling merges and stuff like that. Does everybody use these nice diff tools? Is there anybody just using VI for doing their diffs? It's okay. You get a medal, but also a big slap. I mean, if you're using vimdiff or VI and you cope with it, that's great. But I highly recommend you use one of these because they're just so lovely. You can, the way, so I use Meld because it's very easy to set up on pretty much, I think, did I put the link for it in? No, I didn't. Okay, I should have put, yeah, Meld, I did put the link. It's at the Meld Merge. If you go to meldmerge.org, it's basically a Python-based thingy which you download, and then you can just set it up, and you get diffs. And the only problem is it doesn't work on Daint because it uses some GTK library which isn't installed. So if you are working on machines like Daint, it's well worth considering things like SSH, FS, mounting one of the directories on Daint locally and doing things locally. I mean, it's much, much easier to edit code locally, configure it, build it with your local IDE and whatnot, test it, and then deploy it on another machine. Because we work with Daint, we work with Tave, we work with, it used to be Grainer, now there's, I forget all the names, we've got another machine called Alt. Here on site, we have so many machines, and so having a copy of the code locally, which you can effectively, I use rsync most of the time. I work on my code locally, develop it on the laptop, and then rsync it and build it on the other machines. But things like diffs and stuff, I always do them locally. Now, when you set up a diff tool in your config, and actually, I think I was going to show a slide which shows but I think I've put them in the wrong order. Okay, I've lost it. In your home directory, in your home directory, you'll have, that's not very easy to read, I won't do that. In your home directory, you have a git config, and if you need to set up diff tools, this is how you do it in here. You set it up in your config. You can do git config -- global diff tool, blah, 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 but it's actually a lot easier to just edit it manually. And what the thing to note here is that you tell Git that when you want to do a merge, you want to use a tool, and the tool is called meld, and you can call it, I've called it meld 20 because it's meld version 2. You can call it anything you like. And then you have the actual initialization of it. So there's the diff and merge, and the diff tool and the merge tool, and you set those up in there. And then when you go to, let's have a look. Now, I know that the HPX that I just updated a minute ago, there's some new commits there. The first thing I usually do when I'm looking at a branch which has been changed is I say, well, what's changed on master? And I use DN, which is my shortcut for diff name only. And that just tells me the name of the files that have changed on my copy of the branch and his copy of the branch. And I usually look at that just to say, okay, topology, that could be a problem. I'm working on some of these topology classes at the moment. This gives me a heads up that I better be careful, there might be some conflicts coming. Now, if I want to see the actual diffs, I use git diff tool, which is my shortcut is DT. So git diff tool, I beg your pardon, I have to say git diff tool, and I have to say between my current master and Stellar master. And then it pops up with this and it says, okay, there are some changes. And then I can go through here and I can look through all the changes. And because there's 10 or 20 files which have been changed, it'll give me one of these for each of them, which is a bit annoying at the moment, so I'll stop that. What's actually more interesting at this stage is if I say, right, this topology class, I'm actually kind of interested in that. So what I want to say is give me the diff of Stellar Master of just this one topology class, and then I can look at that and I can see, okay, biff, baff, boff, I can skim down, and actually, oh, this is great. This is actually my stuff that's just been merged, so that's all right. There's not going to be a conflict. Now, there's an interesting thing. If I go to the pull requests page, in fact, if I go to the notifications page, now, if you use GitHub, who uses GitHub? Okay, so okay, who doesn't use GitHub? Okay, start using it right away. It's wonderful. Who uses GitLab instead? Okay, GitLab is also wonderful. The problem is that everybody has their own copy of it, so you have to have 25 logins for 25 projects. But this one, so actually, what I'm looking for is my NUMA binding allocator was actually merged in during the weekend, so that's great. So that's why I've got diffs in there. Anyway, if you don't, so every morning, so one of the things that somebody said is the best way of managing these kind of projects. Now we have, well, you saw that in total there are 90-odd developers who've contributed to HPX, of which 5 or 6 at any given time may be active. They tend to come in and out. Check your notifications every morning. Check who's working on which branches. So actually, I'll come back to this in a minute, because going back to the diffs, if you switch in your configuration for diff, if you switch remote and local round, then you see the diffs the other way round. Now, I've got mine set to the opposite way around to which a lot of people have, and that's because if you say, give me the diff between my current stuff and, for example, head -1, which I haven't mentioned yet, which I should have done, then it's equivalent to saying it sticks your current branch at the end of the command, and that's effectively your local stuff. So I put local on the end so that I see the same. I'm not making myself very clear, am I? If I type in, if I want to know what okay, so if I want to know what the diff between, okay, it's only 2 files, that's fine. If I say, tell me the diff between the current head and the previous head, then you get my most recent stuff on the right and not the left. And that means that it's exactly the same as if you do that. So when you're explicitly, so if I say, give me the difference between branch 1 and branch 2, then branch 2 comes on the right and branch 1 comes on the left. And that's why I have the local set, because I'm confusing you, aren't I? Anyway, okay, back to the slides. Yeah, it's diffs of anything. I mean, you do realize that you can take the diff between your copy of the file at this point in the tree and some arbitrary other point in the tree. Everybody knows this, yeah? That you can just take diffs of almost anything. Because if you haven't used it, this is how you really, when you get into conflicts, when you start trying to fix conflicts, this is where you really need to know how to do it. So for example, if I look at, what I really want is this one here, and I want to say, what's the diff? I can say, what's the diff between my master and Stellar master? Oops. Of this file here, of just that one file. But I can also go and look, for example, at the log of when that file was changed. And I can see, okay, it was changed in November, it was changed in February, it was changed. And what I really want to know is, what's the difference between last year? Okay, this is actually February this year. I can say, give me the difference from February of that file and now it goes back in the tree and it finds the version of the file that corresponds to back in February and the current version that's on. So it's lovely. The fact that I can see the difference in the guys who've just merged something in the remote repository, which I haven't even looked at yet, and the version from last year or 6 months ago, and I can see the diffs. And you need to learn these kind of resolution things for finding these things. I didn't explain what the squiggle and what are they called? They're called the tilde and the carry. Thank you. Yeah. So the tilde is the one you're going to use most of the time, and it just tells you the ancestor. So head is your current state. Head squiggle is 1 back. Head squiggle 2 is 2 back. Head squiggle 3 is 3 back. And the carry is when you have a merge. When you have a merge, you have 2 parents. And if you do a 3-way merge, you can have 3 parents. And what you're looking at then is you're saying carry is the first parent. And carry 2 is the second parent. So when you have 2 branches merging in, you can have carry 1 and carry 2, and they point to the merges. So what Git is doing when you do a merge like this, I'm afraid I can't make these a bit bigger, but when you create a merge commit where 2 of these pieces come in, the commit which represents this part of the branch and the commit which represents this part of the branch, when you merge, you create what's known as a merge commit. And that merge commit, ideally, it's completely empty. All it says is, I'm a node and I have two parents. And it's only when you have a conflict. So he's modified topology, those two branches now get merged. Now that merge commit can have a blob attached to it effectively, which says, they both modified the same file, there was a conflict and we've resolved it, and this is the diff effectively that maps those two branches back together again. So you don't often need, I can't remember the last time I actually used this carry in a command, but I use this one pretty much all the time. Because one of the things you're always doing is you're looking at your, I'm going to check out one of my branches, because then I actually know. For example, if I look at one of these branches, now if I want to know what was the diff between what I'm working on here and what I did 2 commits back, I will just say, give me the diff, and I'll put in like 2 commits back or 3 commits back, and you can see what happened in those last 3 commits, and you can remind yourself, what was I doing, what did I change, that kind of thing. Again, close that back. And you can basically stick in quite large numbers there, although 3, 4, 5 commits, you can normally manage in your head. Anything more than that, and you have to start using other kind of, so I don't use that one. So you probably noticed that my bash prompt here has got the current branch that I'm working on, and it tells me also in here whether I've got new stuff and old stuff. This is really nice, and if you haven't got this configured, I highly recommend it, because when you're working on a project with more than one branch, which is basically all the projects, then being able to see what, especially when you've got another command prompt over here with a different branch in it. Okay, this is okay, I'll save that for. If you do want to set that kind of thing up, in the repository that you've cloned, which in this Git directory, you've hopefully cloned all this already, then I put in, there's a bash git here and some scripts in there, which if you want to copy them into your this is what goes in your bash setup, effectively. We source 3 files, and then you set your prompt, and then it does this nice stuff. The thing to watch out for is that if you do that on daint, oh, I've got the same slide in twice. This is the other one. I meant that one. If you use these kind of bash prompts on a machine like daint on the Scratch file system, sometimes it can be minutes before you see the prompt appear, because Git is effectively scanning your tree to see if you've modified any files, checking those blobs to see if any of them have been changed. It has to do quite a lot of work in the background, and on your laptop and other machines, it's usually fine. On machines with heavily hit file systems, it can be a big problem. How are we doing time-wise? Because I thought I wasn't going to have enough time, but I'm rambling on, actually. We're going to have okay, so reset. So now that you understand, or hopefully you understand, that this Git tree is just a series of commits, and all those commits are points in the file system. The idea of doing a reset, you can basically say, my branch points here in the tree, but actually I messed up, and I want to go back. It's really, if I am at this point in the tree, and the other command that I use 100 times a day is wc, git what changed. It's another alias I've set up, which is in the alias file in your thing. But if you do a git log, it says, these are all the things that changed. These are all the commits you made, which is nice, but most of the time I want to know, what did I actually change? Git wc, which is my alias, it tells me not just the log, but it tells me what files I modified. And this I use constantly. Git status, git what changed, git log. These things are your kind of bread and butter. And again, I've forgotten what I was about to show you. What slide was I on? Oh, reset, that was it. So currently I'm at this point in the tree. That's where my current Git file's head is. Now if I say git reset to head -1 effectively, if I say, what's the status of my repository? What I'm expecting to see is that I've reset myself back 1 point, so now I'm pointing at this point in the tree to this DE22, so there should be git test and unwanted file. Those ones should be effectively modified in my tree. So what I've done is I've said, I was at this point, I'm going to set the pointer to my branch back to here, but I'm not going to change the files. The files are staying the same, so now it's effectively put me back 1 point in the commit to the point where I had created these 2 files, but I haven't yet committed them. This is the fantastic way of when you've got conflicts and things. I mean, you can do some quite clever things, like supposing you've got a branch over here and it's got loads of stuff on it, and you've got a branch over here and it's got loads of stuff. You can reset this branch to be where that branch is, and then effectively what you see is the diff between those 2 branches. Now, why would you do that? It's much easier to just say, give me the diff. Just git diff this branch and this branch. But there are times, for example, when, I don't want to confuse you, but if you have 3 or 4 commits on a branch, and you actually just want to squash them all into one, you can say git squash, you can do a rebase and squash them, but you can just reset the branch back to there and then just recommit all those things. Effectively, you get you've changed. Now, the difference in different types of reset is that this is the one that you'll normally use, this mixed. When you just do git reset head -1, it does a mixed reset. It basically just puts you back in the tree to where you were there, but it doesn't change the files. But it does wipe out any. So if you've already done a git add, git add, those get blown away. They're wiped away, and that's usually what you want. Now, I don't remember the time I've ever used a reset soft. I use reset hard all the time as well, because especially when you've messed something up, you do reset hard. Just bring my working tree back to the state where this commit was. And usually before a reset hard is you create a dummy branch. So you're working on something, you've got conflicts, create a branch at some point to say this is my current state, and then you can do a reset hard. So reset hard is very, very dangerous. I better move on because otherwise I'll never get to the conflict stuff. So conflicts. The first rule of conflicts is try not to get them. And the way you don't get conflicts is by knowing what everybody else is doing in your project. This is the real lesson that you need to learn, is that if you every day check the GitHub pages, look at the current state of the branches, see what's been merged, see who's working on what, keep up to date, then the chances of you getting conflicts is massively reduced. And that's why, effectively, almost every morning, I'll do a git fetch all. I'll look at who's, I mean, it's nice because I've even got, for example, I've got Mikhail's, I've got Hartmut's, I've got Thomas's git repos as remotes in mine. When I do a git fetch, if they've updated branches, even though it's their private stuff that they haven't necessarily wanted to share with anybody, it's a public repo, and they've put it on GitHub, and I can see, Mikhail's working on this branch, Thomas is working on that branch, okay, just mental note. I don't care what they're actually doing, but I know what they're working on, and that means that when I'm working on something, I can maybe ping them and say, look, are you going to be touching this stuff? So you keep up to date with what people are doing. You keep a mental note on what the latest notifications are. GitHub effectively notifies you that all of these branches which are related to things that I'm doing, and it's actually pretty annoying because by the time you've looked at all that, and then there's another project, and then there's another project, and then there's another project, and then by the time you've got through all this, I mean, half your morning's gone. So you don't want to read everything, but you want to know what's going on. So make sure you know what's going on, make sure you keep up to date, make sure you tell people what you're doing as well. It's very important that everybody knows you're working on the topology stuff, you're working on NUMA stuff, and then they won't touch it because they'll keep. So I've said the rest, skip through that. Commit small chunks of work frequently and often. That's my system. If you have, I've got some branches which go back to 2016, I think. I've got some really long-lived branches, and it's really hard to keep those up to date when you only, one of the problems is that you work on something for a week, conference deadline, you do a whole bunch of stuff, it's great, but it's not ready to be merged into master. Oh, after the conference, you go back to something else. This branch sits in your tree, and it stays there. And I've got a branch which I just had to resurrect from 2016, and it's like 3 years out of date. And when you take that branch and you merge it in or you rebase it, it's a real nightmare. And so the more often you keep up to date, the more often you keep your branches merged, if you know that you're going to come back to something. And when you're working on a topic on a daily basis, I mean, you can just commit every day before you go home and push it to your private repo on GitHub just as a backup, because it's very, very easy to squash all that rubbish that you've typed in. What I tend to do is prefix. When I'm working on a branch which isn't ready to be merged, so another alias I have is L1, which just gives me a one-line summary. And okay, I can't see any on that one because I cleaned it. Oh, that's the one that's just been merged. Hold on. Here's an awesome shortcut. BD. It's branch by date. So I want to. Oops, sorry. I meant to say git BD. Give me. I can't type. So. It's in your, when you cloned the repo, you got all these aliases. But when I want to see what branches I'm working on, I've got a little shortcut, git BD, show me the branches by date, and you can see that master I've just updated this morning, then listed as when I last modified those branches. You can see 6th of June, 6th of June, 6th of June, and then we're going to May, then we go to January, and then we go to November, and then we start going back, 2017. I haven't touched some of these branches since then. And I'm very bad because I hardly ever delete branches. I always keep them around just in case there's some little commit that I left on one of them that I want. But if I were to check out, for example, this one, and in this case, the ref's heads just means it's my local. If I do a BD with an R on it, then it gives me also the branches that are on the remotes. And I have a total of 1,243 branches that I'm tracking one way or another just on this one project. And this is because I never delete anything. So I advise you not to do this. But if you have a ref remote, it means this is your remote reference to somebody else's branch, whereas ref's heads is your local reference to somebody's branch. So a BD in my language here is, these are my branches which are local. And you can look at what here's another nifty shortcut. Git LA, list all the aliases that I've got set up. So that actually just goes through my git config file and dumps out the aliases that I've configured. And so you can see the git, BD, the branch date, where is it? This one shows me all the branches which are local, sorted by date. And the BDR shows me the ones which are remote, sorted by date. And this is just really handy when you can't remember. When the problem you get, for example, is you can see I've got 4 different NUMA-related branches here. I'm working on something which is NUMA-related, and I want to make a pull request out of it. Whilst I'm working on that, I think, well, I should also work on this. But strictly speaking, that's a different pull request because they're 2 kind of separate things, so I create another branch for that. Now, the way I tend to work is you have one branch that you're working on where you just put everything into. So you just commit everything, commit everything, commit everything. And then you have another branch which you cherry pick just the commits that you want on that branch, and another branch somewhere else where you cherry pick just the one. So you can have the branch which has got everything on, and then feature branch 1 and feature branch 2, which effectively are the NUMA improvements and the NUMA binding allocator. And then it gets nasty. One of the things that I wanted to mention, which I've only got 10 minutes. Okay, so when you're working on branch NUMA allocator for one of these branches here, and HPX is a big project. If you do a make clean and a make test, could be anything from 3 to 5 hours before you get back to where you were, if you build all the tests. Even if you just build the core, it's 5 or 10 minutes, depending on certain things. So you don't want to switch from this branch to that branch, because if you modified one file in one of the headers which triggers a rebuild of everything. If you're using an IDE like Qt Creator, or if I used to work on Windows machines and Visual Studio, these kind of things, they scan your directories, they scan your folders, they update everything, and you have to rebuild the whole lot when you change from one branch to another. So what I actually do is, and I mentioned earlier, that so you notice here, all my source code is in source, and this is HPX. This is my default. I work on this every day. Here, I'm in source HPX/NUMA. This is where I'm working on a particular branch. Now, this is a completely separate clone. It's a separate clone of the repository with different. So if I do a fetch on this one, I didn't do a fetch on this one this morning, but this has got basically all the same remotes. Now, the nice thing is, you can have, I'll just let this finish. Okay. Okay, so look. I'm in this directory here, which is HPX NUMA. And I've got a remote setup, which is local development. So I have local NUMA, local NUMA something else, and I tend to rename them and delete them and recreate them. But local dev is in my home directory on this machine. I've got a remote repository set up in another directory of the same machine. So I can push and pull branches. So when I commit everything, if I'm in my dev branch here, in fact, this one's a misnamed. I was renaming them before the course and I messed it up. But anyway, but if I'm in this local dev and I'm working on stuff and I commit something, then when I go into the other directory and I do a fetch, it says, oh, locally you've committed all these things. Then I can cherry pick them into this thing and I can say, I just want that commit, just want that commit. And I have 4 different source trees, 4 copies of the same source tree, all with remotes set up to point to each other. So depending on which branch I'm working on, and it's only, now if I was working on a small project, I wouldn't bother. So if I could check out branch 1 and build everything in a minute, then I would just do that. But because HPX is massive, and it takes me 10 minutes, and then you touch all these files, and then Qt Creator spends 15 minutes rebuilding all, because it does all the syntax highlighting and all the symbols for the debugger, and all of this stuff is going on. So I actually have multiple copies of the tree, and cherry pick between different copies of the same effectively the same. Now, I didn't realize it. I used it years and years and years ago, but somebody actually created a tool which is called Git Workdir. I haven't even got to all this stuff. Goodness, we need an extra session now. Okay, it's way down in my list. There's a command called Git Workdir, which lets you do what I do, but in a slightly more Git. Okay, let's just get going. There's a command called Git Workdir, and it lets you effectively set up multiple copies of the same source tree, but without having to physically duplicate everything. So effectively, you can have, what I've got is source tree 1, source tree 2, source tree 3, and they're complete Git clones. Git Workdir lets you do effectively the same, but working from a single clone and just sharing branches, but having multiple source trees. I must investigate whether or not that's any use. So, okay, so the other strategy for avoiding conflicts is get your stuff in first. Because if you've modified the topology stuff and you get your PR in, then whoever else is working on it, when they try and merge their stuff, they get the conflict and you go, excellent. So commit frequently, commit small, and get your stuff in first. And the way you get your stuff in first is by knowing what the other people are doing. So if you know somebody's working on a feature and you think, oh, bugger, when they put that feature in, it's going to break everything, you want to get your stuff in first, and you want to delay them as well. I'm not saying sabotage the project, but you need to say to them, well, are you really sure it's ready for committing yet? Because I've got some really important stuff that needs to go in first, and tell them. Anyway, so 3 options. Also, because you can share your repository with the other person, you can say, look, I'm working on this branch, and when you commit yours, it's going to break everything. Could you have a look at my branch and merge it? Because the thing is, merging your code is so much easier than merging someone else's code. Merging someone else's code, you think, conflicts, did he mean this or did he mean that? And then you end up having to speak to them. If you can say, look, I've pushed a branch, could you pull it, have a look at it, and try merging it, and then resolve whatever the problem is? He can probably do it in 5 minutes, and it'll probably take you 3 hours. So option 1, get someone else to merge your stuff if you don't know what it is. Option 2, get your stuff in first. And option 3 is when the other person gets their stuff in first, and then you're left with all the conflicts. And then life sucks, but that's the way it works. Somebody asked in the questionnaire about merge strategies, and there's actually lots and lots of different algorithms that Git, well, there's a couple of algorithms that Git can use. I don't really know much about them, but I never use any of this by default, overwrite everything in mine with ours or theirs or any of that. I always manually reserve conflicts because I'm too scared of letting Git do something and not quite knowing what it's doing. It's much better if you who's used git re? Nobody put their hand up. Okay, you need to know about git re. Replay recorded resolution. So every time you check out somebody's branch, you merge somebody's branch into yours, and it says conflict, and you go, bugger, conflict. And then you look at the diff, and you think, okay, I see what he's done. He's modified this, I've modified that. We need to shift that bit there, we need to shift that there. You create a conflict which is resolved. Now, if at some point in the future you say, well, my branch has got that one merged in, and now actually master has moved on, and I'm going to rebase my branch onto master because it's nice and clean that way, you'll get the same conflict again, because the order, when you take 2 commits and you merge them, this parent commit and this parent commit formed this child effectively with a conflict resolution, a resolved conflict in it. Now, master is over here, and then at some point, you say, well, I'm going to take my branch, which I've merged stuff in, and I'm going to rebase that onto master. Now, rebasing flattens your code into a linear sequence of commits. Now, any of those merges that were going on over here, or if master has already merged in some of this stuff, then when you replay your commits onto master, those 2 commits which you resolved the conflict for, they don't really exist anymore because they're now different commits. When you merge... When you create a diff, when you create a commit here, and there's a commit here, and then you rebase that one, if there's a branch point here, so this is the master, this is your branch, this is this branch. When you rebase this onto here, the commit difference between here and here is not the same as the commit difference in here and here. So you frequently find when you fix something in a merge and then later do a rebase, you get the same conflict. And you think, I fixed this already. Turn on re, because what it actually does is it basically, every time you resolve a conflict, it makes a snapshot of the branch A and branch B, what the 2 diffs were, and then what your resolved conflict was. Now, even if that diff gets merged into a different branch, and this diff gets merged, this commit gets merged into that branch, and this gets merged into that branch, and then later you do a rebase. Even though the branches that you're rebasing might have changed, the actual diffs are the same, and Git will spot that, and it will say, I'll have to schedule one of the EasyBuild or Spack sessions will have to run short, and I'll carry on with all the conflict stuff, because anyway, it'll save your life. It means you only have to do the conflicts once instead of lots of times. And you can turn it on in, I don't know why I've highlighted that. It's in here somewhere. This is the wrong slide. I don't know why this is here. This has got nothing to do. Can anybody see anything on there that's to do with re? Okay, forget that. It's coffee time. And I was going to show you about how to use things like meld for doing conflicts, because it's nice. But we should probably keep on schedule. Do you want me to keep talking after the coffee break? Or do you want to get straight on with Git? Who's enjoying Git? Hands up if you're enjoying it and you want more. And hands up if you want to go straight to CMake.
Hands up if you want to do one.
Okay, after coffee, we'll keep to the plan. We'll do CMake. We'll have coffee. We'll do CMake. And then if later on this afternoon or tomorrow we have some unused time, we'll come back to that. And if you want to ask me questions in the meantime, I'm here all day today, I'm here all day tomorrow. We can just sit and we can do stuff together. And so what I was going to talk about was conflicts, The ref log, what it is. Everybody knows what the ref log is, don't they? Yeah. It basically just stores a list of everything you did. And then you can say, well, I merged this and I shouldn't have merged that. And the ref log says, well, just before that merged, you were at this state, and you can just go back to it. And you can reset back to things. The stash is awesome. You made some diffs. You want to pull in another branch, you stash everything. You pull in the other branch, and then you play the stash back. And effectively, you've done a free branch without having to bother with it. Bisect. Nobody uses bisect anymore because we have continuous integration. We have testing. And okay, nobody uses bisect on projects like HPX because it takes 5 hours to build all the tests. So if you said, somewhere in this 100 commits, we introduced a bug, and then bisect says, this one was good, this one is bad. And it says there's a linear, effectively a series of commits between them. There may be merges in. And what you do is you say, mark this one as good. So you say at the beginning, you say, currently I'm on this branch and it's bad. It doesn't work. So you say git bisect bad. And then you say, I know that the tests all passed on this commit. And so you say git bisect good, and you say commit where, and it may be a week ago. Now what Git will do is it'll do a binary search. So what you do is it checks out a commit somewhere in the middle, and it says build and test. So you build and you test, and you say, no, it's still bad. And it says, okay, it's still bad. We go back halfway, and it does a bisection. Now, if you've got a project which takes 5 minutes to build, awesome. If you've got something which takes 4 hours, use continuous integration. Because you can usually just look at your daily dashboards and say, something was wrong on the 4th. Now, sometimes the tests will pass, but everything's running at half the speed. Now, that's a bit trickier to find because you need to find those, and then maybe you do want git bisect. This is expensive and tough, and you should use it as a last case. Unit testing is usually better. Sending patches, nobody does it anymore, but it still exists. People argue about merge squashing and merge rebasing, and I didn't realize how awesome merge squashing was. So we can talk about that during coffee or whatever. Let's have I canvassed people to find out why they like merge squash, and I've almost been convinced that I should start using it. Because I use rebase all the time. I rebase everything constantly because I like a nice clean history. And okay, quick note about rebasing and squashing. So whenever I do a pull request, I check out master and I take my code and I rebase it onto master. And why do I do that? Because most of my branches are about 3 years old. And if you have merges coming in, going back so far in history that you're trying to look at the log, you have no clue what you did all that time ago because it's so far back in the log. But if you take your branch and you rebase it onto master, you've got the current master, and then you've got all the changes you made in one clean thing. Now, you get horrific conflicts, so it takes time. But the nice thing about rebasing onto master is that you can see a nice clean log of all the things you did, and you can squash these two and say, that's rubbish. Put those two together. Okay, that's just debugging. I can just merge that with that. And you can compress diffs. You can compress commits into each other. Now, if I have a short-lived branch, which is just a few fixes, then I don't usually bother with that. But other projects use a squashing approach, whereby all the commits, you have a branch, it's got 100 commits in it. When you merge it into master, you can merge minus squash, and you can do this on GitHub with an automatic, I think I had a snapshot there. You can actually say, this project. So in HPX, we just use a merge. So when you merge a branch in, it just creates a merge commit, boom. You can say to it, do a squash. And what GitHub will do is it'll compress all of those diffs into a single one. So you basically got this branch and this branch, one massive diff with everything that went from there and there, and it'll concatenate all the logs together. Now, why is this awesome? It's awesome because if you've got continuous build testing going on, and your testing is running every PR, then you know that every point in the master, which was merged from a pull request, passed the builds and the tests and everything. When you use the rebase approach like I do, then what happens is I know that at the point I made the pull request, everything passed, but most of the stuff in between is just total rubbish. because I didn't actually run half the tests on those. I was working on something, this is an interesting fix that, fix that. And I know I haven't broken the test because I know what I'm changing, but the unit testing hasn't necessarily been done. So the merge squash is actually a very nice way of meaning that somebody can go into your public-facing repository on GitHub. They can basically go to any commit, pull it out, and they know that it'll build and run and test and everything will be clean. Whereas with HPX or something, you could pick a random commit somewhere. You don't have that guarantee. And anyway, so we can go on, but let's have coffee.